So this is standardization of sulfuric acid using sodium triisocarbonate 4. If you could remember in our previous experiments, we've dealt with what standardization is, primary, secondary standards, right? So to standardize mean to determine the concentration of a given solution. So in this case, this experiment will be concentrating on the determination of the concentration of sulfuric acid using sodium triisocarbonate 4. That is what standardization means. Remember also in our previous experiments how these primary standards serve as reference points in the determination of unknown concentration. From this title, we can actually say that our primary standard of high purity stability is sodium triisocarbonate 4, while the sulfuric acid, which we'll be standardizing, is our secondary standard, and it is not as pure as the primary standard. And that is why at the end of this experiment, we'll be standardizing it, that is determining the concentration, and we'll also be determining the percentage purity, because we'll be served with a concentration of sulfuric acid that is impure. You see, secondary standards are not as pure as primary standards. Having known that we have our primary standards to be sodium triisocarbonate 4, whose concentration is known and given to be 0.05 molar. You have to note that that is the concentration of the sodium triisocarbonate 4 serving as our base. You're expected to prepare the solution in 250, all right? So you have to make a calculation and prepare same solution in 250, meaning it's also the same concentration. So all this we've already covered in our previous experiment. So how would you prepare the 250 cm cube of the 0.05 molar standard solution of sodium triisocarbonate 4? Once you're able to do that, that is what you would employ to carry out this experiment. Now, in this experiment, sulfuric acid, as we've said, is serving as our secondary standard, and it is not as pure as the sodium triisocarbonate 4, which I've said earlier. And that is the essence of carrying out this experiment, to determine the concentration of sulfuric acid and its percentage purity. Now, we shall be employing a titrimetric method to determine the concentration of the impure acid, which is the sulfuric acid, using sodium triisocarbonate 4 as the primary standard. A solution of the impure acid will be provided, of course, containing 1.25 gram per 250 cm cube. Note that the solution of the impure acid, this is the concentration of the impure acid that has been given. So you're going to make use of this data somewhere else in the course of this experiment. And like I said previously, our sole aim is to determine the concentration of the impure acid using sodium triisocarbonate 4 and to determine its percentage purity. Generally, we have a relationship used in acid-base titrations that will be employed to achieve this. Now we have this relationship. You can see over here CAVA divided by CBVB equals to A over B, where A is the number of mole of acid, B is the number of mole of base. And how do we get to know this? It's from the balanced equation. You have to write an equation of reaction between the acid and the base, and look at the acid to base number of moles once you've balanced it on the left hand side. That is the reactant side. Now Ca is the concentration of the acid in molar or mole per dm cube, and this concentration of the acid is that of the pure acid. Now This is the unknown. Ca is the unknown. Cb is given, which is the concentration of the base in mole per dm cube, which is the molar concentration. It has been given, which I've stated earlier. Now, Va is the volume of acid used. This you can actually derive from your average titer value. You have to carry out the titration like 3 times or 4 times. Take the readings that are very much precise, the average readings, and that would serve as your Va, volume of acid used to neutralize the base. Remember, the acid goes into the burette, all right? So Vb is the volume of the base. That's the volume you've taken, and it's dependent on the volume of pipette that has been given to you. You would be given a 25 volume centimeter cube volume or 50 centimeter cube, as the case may be, whichever you're given. So that would be serving as the volume of base that you'll be taking for this titration. Now, to determine the concentration of the pure acid by titration, because that is the essence, you're going to use the same formula. Just make Ca the subject, all right? Substitute in your values. And remember, we are working in mole per dm cube. So whatever volume you're given in cm cube, try to convert them to dm cube. For example, 25 cm cube of the base that was pipetted, that is Vb, you should divide that by 1000 to convert it to dm cube. Likewise, your volume of acid used, whose value is in centimeter cube, you would have to divide it by 1000 to convert it to dm cube in order for you to use it in this formula efficiently. All right, so once you've done that, you should be able to get the concentration of the acid. And you're also expected to determine the concentration of the pure acid yet again in gram per dm cube. Remember, in our previous experiment, gram per dm cube signifies mass concentration. Don't forget the relationship. So from this relationship, from our previous experiment, you should be able to make mass concentration the subject formula, and you already know what your molar concentration is, which is in mole per dm cube. You've calculated that. All you have to do is multiply it by the molar mass of the acid, and there you go, you get your mass concentration in gram per dm cube. You're also expected to determine the concentration of the impure acid, right? Remember, I said you should take note of some data before we started this lecture. Now, you can find this by relating to the impure sulfuric acid solution concentration you were served. Remember, 1.25 gram was served in 250 cm cube. So how would you determine the concentration of the impure acid in gram per dm cube? All you have to do is convert. All right, I believe you can do that. So once you convert it, you should be able to know how much of this is in 1 dm cube. That is, how much is in 1000 cm cube. Just do your ratio relationship to get that. Now, finally, you determine the percentage purity. And to determine that, you have to consider the mass concentration of the pure acid divided by the mass concentration of the impure acid. All of this you've already calculated. So from here, you should be able to get the percentage purity and state suitable precautions that you've taken.